Hello everyone and welcome. In this video, I'm going to be giving you a very short trick to predict the ozonolysis product of alkenes and alkynes. Now, from the word ozonolysis, the word lysis means breaking down. So we are breaking down alkenes and alkyne by the addition of ozone. So that's the meaning of ozonolysis. If you are to ozonize a substance, it means that you want to break down the substance by the addition of ozone. So if you want to do that, let's consider alkenes generally. Normally, alkene will have a carbon participating in the double bond, and we can have this as well. So let's say this is R1, R2, R3, R4, and we are adding ozone to this. Now, what will happen is that the alkene will have double bond, and here is the double bond. The moment you add ozone to this alkene, it is going to break down alkene across that double bond. Because when we are saying that we are breaking alkene, we are going to break it at actually the double bond it has. So we are going to break this alkene here. So, and when you do that, you have these two fragments, R1, C, R2, double bond C, R4, and R3. So now the next thing is now to add oxygen, and you add oxygen to these two fragments. So that will be the product of ozonolysis of alkenes. Now sometimes the alkene might have hydrogen, as opposed to the alkyl group that we have here. So it might have just an alkyl group and hydrogen. So you would still do the same thing when you react this with ozone. Don't forget it's O3. It is going to break this double bond, and if it breaks that, we're going to have the two fragments as well, so which are the first one and the second one. So we have these two fragments here. Now the next thing is to add oxygen to that double bond. So you add oxygen, and that's going to be your product. So we have two possible products for ozonolysis of alkenes. Remember, we are considering alkenes first. So the first product is when the two things attached to this double bond is attached to the carbon bearing the double bond. When the two things attached to it is alkyl, we're going to have an alkanone, because if you look at this is an alkanone. We have the alkanone here, and when we have just one hydrogen, we have aldehyde. So the two possible products of ozonolysis of alkene are alkanone and aldehyde. Please make sure you note that. Now, so that is the general rule, the general shortcut for the ozonolysis of alkene. Now let's look at some examples. You might see in your past question that predict the ozonolysis product of X3N. You asked to predict the ozonolysis product of X3N. So the first thing is to draw X3N. X we have 6 carbon. Okay, X we have 6 carbon. Now at the third position we're having double bond. So that is around this place. If you count from here, we have 1, 2, 3. So that's it. And you have to like put the hydrogen to saturate it. And we have this. We have just one hydrogen here. One hydrogen, CH3. So this is the X3N. Now they are asking that what will be the ozonolysis product of X3N. So all you have to do is just to break it across the double bond. You break that double bond, and you have just two fragments. The first one is H3C, CH2. I mean this is CH2. Okay, so then we have CH double bond. Okay, and we also have double bond CH2 for this, and CH3. Then the next thing is to add oxygen. So you add oxygen to this, oxygen to this. So these are the two products of ozonolysis of X3N. Now you have to name them. Now generally to name, now if you have any carbonyl compound, this is a carbonyl. Okay, if you have alkyl attached to it, Now, if what is attached to it next is hydrogen, this will become alkyne. And if what is attached to it next is R, it become alkanone. So if you want to name them, what you have to do is just to you have to find the total number of carbon that compound has. So that will represent this ALK. So they are the Greek prefix. If it is 1 carbon, that's going to be meth. If it is 2, that's going to be eth. 3, that will be prop, and so on like that. So here we're having 1, 2, 3 carbon. So that's going to be this one because it is having hydrogen and alkyl group. So that's going to be prop, okay, anal. So that will be propanal. And here too, it should be propanal. So the product of ozonolysis of X3 is 2 molecules of propanal. Let's try one more example. You might be asked to find the ozonolysis product of X2. You're going to get 2 different products. So X2, you have to draw that. So this is going to be X2. So this is going to be X2. At the second carbon, we are going to have the double bond, and we are going to have CH, CH2, CH, 1, 2, 3, 4, 5, 6. When you add ozone to this, that's going to break the double bond, and if that happens, you have H3C, CH double bond, CH. This CH means that the carbon is attached to the hydrogen. We have CH2, CH2, CH3, and you add oxygen, So these are the 2 products you will get, and this is going to be an alkyne because it's having hydrogen. So that's going to be 2 carbon, that's F. Okay, so F and now, and this is going to be 1, 2, 3, 4, that's boots and now. So that's the ozonolysis product of X2. Now you would notice that all this while we are actually getting aldehydes, which are alkanes. So let's try the ones that we are going to get ketone. Let's say, for instance, you have to find the ozonolysis product of hept 3-methyl, hept 3-ene. So hept 3-ene, hept is having 7 carbon, so that's going to be X. Hept, that's 1, CH2, CH3, because we're having 3-methyl, and still we're having double bond, CH, CH2, 1, 2, 3, 4, 5, 6, 7. So this is 3-methyl hept 3-ene. So all you have to do is to break the double bond, and if you do that, you're going to have H3C, CH2, CH3, double bond, CH, this fragment, CH2, CH3. Then put the oxygen. When you look at this is actually C double bond O. Okay, this is C double bond O. Then we're having CH3 attached to it, and also CH2CH3, this one. Okay, and here we're having C double bond O, an hydrogen, and also a propyl group attached to it. So that's an aldehyde, and the name of this is going to be 1, 2, 3, 4. That is going to be butanone. But the functional group is at the second carbon. That's going to be butan, 2-one, and this is going to be 1, 2, 3, 4. That is going to be sorry. This should be this is going to be butan 2-one, and this 2 will be 1, 2, 3, 4. That's going to be butana because having hydrogen, that's an alkyne. So that will be buta. Now, so that's going to be the ozonolysis product of X3. Now let's look at the ozonolysis product of alkynes. Sorry. So that's all for alkene. So now for alkynes, if alkynes generally they will have triple bond. So they will have triple bond like this. So when you are reacting alkynes with ozone, of course the double bond still has to break, but in this case it's not going to be either alkyne or alkanone, but rather it's going to be carboxylic acid. So let's say these two are different. So what we are going to do next is that you are going to add oxygen. Normal, you add oxygen. Then it was triple bond before. It's going to be double bond here. Okay, just as the way we do for alkenes. But the next thing you need to add is now OH. You now add OH to that carbon. So this is going to give you, it's like RC double bond OH, which is an alkanoic acid. So that's just the only difference between that of alkane and alkynes. So in this case, if you have to find the ozonolysis product of maybe heptine, the ozonolysis product of heptine, let me use the stick formula. Heptine, we have 7 carbon, 1 2 3 4 5. So 1 2 3 4 5 6 7. So let me do it this way. So let's have triple bond here, something like this. So that will be 1 2 3 4 5 6 7 8. So let's call it octane. Octane. Don't forget, when you are drawing the strict formula for alkynes, this and this, they are 2 carbon, and this one is the first, second, third, fourth, fifth, sixth, seventh, eighth. So this is going to be octane, like that. So if you want to do it, you have to break the double bond. Let me redraw it. It's going to be something like this. Okay, something like this. So it's going to be something like this, and you have to break the double bond. Okay, so when you break the double bond, you have something like this. Okay, with double bond oxygen. Then that same carbon, you're going to add OH, and this one is going to be just like this, oxygen, and we have OH. So this is going to be 1 2 3 4 5. That is going to be pentanoic acid, and this is going to be 1 2. That's going to be that's going to be 1 2. That is going to be, instead of that, we are supposed to have from here 1 2 3 4 5. This carbon 2 is 6, right? Then so this should be hexanoic acid, something like this. 1 2 3 4 5 6. So this should be hexanoic acid, and this is going to be ethanoic acid. Let me draw the normal skeletal stuff that we know, the condensed one. So for octane is going to have HC triple bond C CH2 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 CH 1 2 3 4 5 6 7 8. Anyway, it depends on the position of the triple bond. Here I was putting the triple bond at the second position, where you count from here 1 2. So it's at the second position, but here it is at the first position. So it depends on the position. So if you want to ozonize this ozone, so that's going to just cut the triple bond, and we're going to have HC. You put the double bond oxygen, and you put OH. Here you will just put double bond C, the C, and you are going to add OH there. You add O, then you have CH2, 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 CH3. So this is going to be meth, because it's having 1 carbon. That will be methanoic acid, and this is going to be 1 2 3 4 5 6 7. That's going to be heptanoic acid. So the ozonolysis product of octane, or 1 octane, is going to be methanoic acid and heptanoic acid. So that's going to be the end for this video. Thanks for watching, and I do really appreciate it. Please make sure you like the video, subscribe, and share the videos with your friends. Thanks for watching.